So we are given this polynomial function, f of x equals 8x squared times the quantity of x plus 4 times the quantity of x minus 5 squared. And what we want to do is find all of the zeros of the function according to their multiplicity. All right? So first of all, let's find the zeros. What are the zeros of this function? Well, by definition, it's going to be wherever f of x equals 8x squared times the quantity of x plus 4 times x minus 5 squared. It's wherever this is equal to 0. In other words, it's where 8x squared times x plus 4 times x minus 5 squared equals 0. Well, by the zero product property, that's going to occur when 8x squared is equal to 0, or when x plus 4 is equal to 0, or when x minus 5 is equal to 0. In other words, when x is 0, when x is negative 4, and when x is equal to 5. So these are my zeros. Okay? These are my zeros. That doesn't, however, tell us what the multiplicities are. To do that, we need to look back at the original function. And the multiplicity is just going to be whatever power that part of the function is raised to. For example, this x is raised to the second power. So the 0 I get from this part, which is right here, the 0 I get is 0, is raised to the second power. So that has multiplicity 2. So that is the 0 of 0 has multiplicity 2. Now, this x minus 5 squared, this x minus 5, the 0 I get from that, which is 5, is raised to the second power. That also has multiplicity 2. So I'll put a 5 right there. But this x plus 4, which gives me the 0 negative 4, this is raised to the first power. So that has multiplicity 1. So that's a 4. Now that's how you can find multiplicities, just looking at if you have the function itself in nice factored form like that. You can actually solve it for 0, get all the zeros, and then see what powers they were raised to find their multiplicities. Oh, and also, how many multiplicity 3? Well, they're none. Okay, they're none. But we can also use the graph of the function to find the zeros and the multiplicities. Here is the graph of that function. I graphed it on Desmos again, and then took a screenshot of my laptop to get the screen right here. But let's answer that same question. Find the zeros and their multiplicities. Well, remember the zeros are where the graph of the function crosses the x-axis. So that happens here, here, and here. So we can tell. We can't tell whether the multiplicities are, a multiplicity of 1, 2, or 3 necessarily. But just looking at the graph, we can tell whether it's odd or even, which then looking at the function itself can give us some more information. So here's what I mean. Here at x equals negative 4, I know that there is an odd multiplicity. And that's because the graph of the function is crossing the x-axis. Here at x equals 0, there is an even multiplicity. And that's because the graph of the function is kissing the x-axis and then going back up. It doesn't cross it. It just touches it and then goes back up. And here at x equals 5, that 0 has an even multiplicity. Now, like I said, you can't necessarily tell exactly what the multiplicity is by looking at the graph, but you can tell whether it's even or odd. And if you do have the function that is written out like this in this nice form, even without going through the algebra of solving it for 0, the 0 comes here, the negative 4 is going to come from here, and the 5 is going to come from here. Which tells you this odd multiplicity has to be 1. These two even multiplicities have to be 2. Okay?